This is Honors Geometry Inscribed Angles Lesson 2. So the last lesson we discussed that an inscribed angle, it's made of two chords with vertex on the circle. It creates an arc that's twice as big as the angle. So in this example, if we take 88 and double it, the arc that it creates, its intercepted arc, is 176 degrees. We know a full circle has 360 degrees. So if we take 360, subtract the 176, looks like we have 184 degrees left over. What that means is the rest of the circle is 184 degrees. If we look at the inscribed angle that uses that 184 degree arc, big to little, we cut that in half, we can see that y would be half of 184, or 92 degrees. Now maybe you noticed the secret already about the 88 and the 92. You probably noticed that they add up to 180 degrees. That's because the two angles together use the whole circle. And when you cut that 360 in half, we have 180. So that's the secret on today's lesson, that if you have a quadrilateral inscribed in a circle, that means all four vertices have to be on the circle. We know that opposite angles are supplementary. They add up to 180 degrees. So we're going to take that shortcut to find x. So we're going to take 180, subtract the 108 we're given, and it looks like x would be 72 degrees. All right, let's try again. We're going to use our shortcut now. So to find x, we know that it's half of the arc. We don't have x or y, so we're just going to start with this. So we're going to add the 58 and the 106. 58 plus 106 looks like that's 164. Big to little, we're going to cut that 164 in half, and so we know that x equals 82. We're going to use our new shortcut that says angles, opposite angles of an inscribed quadrilateral have to add up to 180 degrees. So we're going to take 180 minus the 82. It looks like y is going to be 98 degrees. So how do we figure out what z is? There's a couple ways. One is you know that all quadrilaterals have 360 degrees. The other way is, let me clear up some work here. The other way, we could easily just say that we know opposite angles are supplementary. So we're going to take 180 minus the 93. So 180 minus 93, it looks like z is going to be 87 degrees. All right, let's throw a little algebra in with that. So we're given that this arc is 10x minus 12 plus 80. So we're going to combine that together. That's going to give us 10x, what's that, plus 68. And big to little, we know we're going to cut that in half. So we're going to divide that by 2. And then that's going to be equal to the angle, which is 7x plus 10. Maybe some of you are saying, hey, I think it'd be easier to go from little to big. That's fine too. If you'd rather, we could take 2 times 7x plus 10 and then set that equal to the arc, which we decided was 10x plus 68. We should get the same answer, whatever's easier for you. I'm going to take 10x, divide it by 2, that gives me 5x. I'm going to take 68, divide it by 2, that gives me 34. equals 7x plus 10. Let's get our x's together. Subtract 5x from each side. Subtract 10 from each side. Looks like x is going to be 12. And let's try one more together. Let me make some more space here. And change colors. All right, here we go. Where do we want to start? We know that this whole arc from B to Y is going to be 144 plus 90. So it looks like that's going to be 234. We know that the angle that creates that arc is going to be half of that. So we're going to take that 234, big to little, we're going to cut that in half. So divide that by 2. It looks like this angle is 117. Now, to answer their question, what's the measure of the angle across from that? We learned today that you take 180 minus the 117. And it looks like our missing angle is 63 degrees. All right, please try the practice problems. If you have any questions, send an email. Thank you.